and thank you very much for the presentation. So I'm José Hernández, as Ignacio said, from CARTIF Technology Center, placed in Spain. And yeah, I'm going to talk about the data quality in this sense, because we are talking about machine learning, about the decision support systems, about different parts, but we are training models with, and we don't know the quality of the data that we use to train these models. So can we rely on the models that we develop? So this is the key question that I'm trying to answer today. So basically, as I said before, why we need this data quality. So we are currently in the digital transformation of the building stock. So we're in the process currently. And with this part, we have the management part, we have the operation, we have the management, we have everything in the building, we have data, we have sensors, and we are going to apply Internet of Things, big data, artificial intelligence applications in this context. And in the process of applying this process, we are gathering data, we are collecting data, but of course, the systems fail, and we need to assure that the data we have to train our models is enough. So in the digital transformation, we should consider all the chain of this part. Over this process, we have a lot of problems in the data, like for instance, gaps, errors, outliers, inconsistencies of data. And this data will help us to provide better informed decisions. So imagine that we have outliers in our data, and we're taking decisions based on these outliers of data, or not having the full stock of data. So we are going to take different decisions based on this data. So that's why it's very important at the same time. And of course, not taking biased decisions, because these outliers as well can provide us some decisions that are wrong in our building, and at the end will be more discomfort of the occupants, will be more energy consumption, etc. And we need to rely on these results. So we have the models, as I said at the beginning, and can we trust on them? This is the question and that we have. And of course, interoperability. We have a lot of systems, so we can imagine a hotel like this. They will have different systems, different trademark, different vendors, different elements, and we need to assure that everything is interoperable and connected in order to make decisions. Because if we miss some part of this data, we will have problems at the time of making decisions. So that's why it's very important to comply with all of them. And in this sense, in the GBuild, we have 7 dimensions of data quality that we have defined. You can see in the screen. So we have accuracy, completeness, reliability, consistency. That is the focus of today. But at the same time, we have relevance, accessibility, and timeliness. So let's say that accuracy is when we have expected data in place. So this means, for instance, in a room, we expect to have between 15, 25 degrees, like in a room like this. So every data that is out of these temperatures is considered not accurate. This doesn't mean that it's not valid. This means that it's not accurate according to our standards or our thresholds. Completeness, having the full stack of data. Reliability, the combination of accuracy and completeness. We have also consistency, that it determines the patterns of the data. So this is being very close to machine learning and artificial intelligence applications. So data is usually distributed in a pattern. So if the pattern is not compliant, so something happening. But again, this doesn't mean this is not valid data. This means that something should be checked, and because our decisions will be based on data that is not consistent enough. In the other side, we have relevance. That means using the relevant data for our decisions. Sometimes we have a lot of data in our context, a lot of sensors, a lot of information that is being compiled, but we really need all this data. Accessibility in order to access the information that is needed for our decisions, and timeliness, having the data in the time that we need to have this data. And within the GBuild, we have 2 processes. This process was presented in the last year of the conference. This is the checker part. So we have divided in 2 steps. In the step of the checker, we have 2 ways to check the data that we have. One is manual and guided by the user, and secondly is automated in the ETL's processes in order to collect the data. In this sense, we are able, as I mentioned at the beginning, to calculate 4 indicators at the end: completeness, accuracy, reliability, and consistency. And in case that we use the user guide process, the user will be able to upload the data that the user wants to check, and of course accommodating the data, formatting the data, so for the user is completely transparent, so we have the full process. And in the case that we have the ETL process, we are able to calculate in this data set that we are collecting in the ETL these indicators. On the other hand, we have the corrector. So once we detect the quality that we have the indicators of the data, and we have to correct the data. So in this sense, the trigger for us is to have the 90% of completeness. So whenever we have 90%, less than 90% of completeness of data, the corrector will enter into the process. So this process is gathering the data that we have in the historical part. We apply different machine learning models because we have different types of data. So in energy case, we have usually cumulative data. This means linear regression is usually the best pattern to fill the gaps and to fill the data that we don't have. But in the case of temperatures, humidity, or other variables, we need different processes, like having different models, like random forest or other kind of models, in order to determine the patterns of the temperature, for instance, in order to correct this data in the back part of the time. And also, we should consider discrete variables like occupancy, that is 1, 0, or this kind of variable. So we have like 3 different models being applied, depending on the type of data, considering different variables like seasons, like conditions, standard conditions, etc., in order to fill this data. And with this, also, of course, we clean the data of the consistency and accuracy parts, or layers, and so on, in order to correct this data and to improve this part. I will go very quickly to this slide because this was the focus of the presentation on the previous year, so you can check all the indicators of the pilots in DigiBuild. We have 10 pilots. We can check all this data, all these numbers in the previous year paper. Basically, we have all these pilots in our project. We have different, you can see the different frequency, different protocols, so data is very heterogeneous in this case, and you can see the numbers of the pilots already, so very diverse numbers. So we have some pilots with very high level of quality and others with less level of quality, but I will focus now in one of the cases, in the NTUA case, that is at the end. And in this case, we can see one of the data sets. This is for the outdoor temperature that we have in this pilot, just this variable. So you can see that there was a part of the data set that is not completed with data, so it was not, the sensors were failing, and then we didn't compile data, so we have a very big gap of data. Indeed, you can see that the completeness is almost 50%, a bit higher than 50%. We have accuracy, very high, or well accuracy, that is 76%, and 50% of consistency. So once we train the model, we interpolate data with the red lines that you can see in the screen, and we increase the completeness until 100%. So this means we have a full stack of data. Of course, we have a flag in our database to detect when it is synthetic or when it is real data, in order to also to filter the data whenever we want. So it's possible. We increase also consistency and accuracy. The reasons why is because we are using, as I mentioned before, clean data in order to train the models and then to interpolate the data. So we are improving the quality of data. So we have data that we can rely more in order to train different models. The data, we also, of course, the indicators are checked according to the patterns of data in a full stock of data, like 2 years of data. So the question of if we can rely on or not in this data, it can be answered also because we have models that with the error, it's very, very low error in the training, and we have also checked the data, the patterns of the data with 2 years of previous data. And just to finalize this part, I would like to conclude with some key points that we detected in this work. So first of all, we need to increase the data quality that we have, because we need to rely on the models that we are applying. We need to rely on the things that we are doing and taking better informed decisions. So we cannot rely on the data that we have already, because the quality, and you saw in one of the slides that the quality, let's say, that is not high enough to make decisions and to train some models. We focus on different indicators, and these indicators are taken from the literature and the bibliography, so we are using already a good fundamentals in order to train our models and to use this indicator like completeness, accuracy, reliability, and consistency. In this sense, we use a centralized data lake in order to assure the interoperability, also to integrate real-time data, and we are using this centralized data lake in order to provide all these data quality mechanisms and providing information to the system. And of course, not only about decisions, so we have in the European Commission, we have the EPBD already, and we have different directives from the European Commission about the digitalization, so we need to assure that the data that we use to digitalize the building stock is quality enough. And last but not least, this is a method that is not only used for this project, so it's used also for different, beyond the project, to different pilots, to different parts of different buildings, so we can consider this method is scalable and replicable to different contexts. And yeah, that's all from my side. Thank you very much, and open to questions.